talking about the specification of processes, and we said that there are three different methods of specifying processes. One is called structured English, which is very similar to programming languages, which you have learnt already. The other two are, one is called decision tables, and the third is called decision trees. And decision tables are useful for complex decision processes where the number of conditions to be tested is quite large, and it also gives a non-procedural method of specifying the business rules. And if a sequence of taking actions or sequence of testing the conditions is important in any given problem, then you go to something called decision trees. So, I will look at all these three, and today I will start with looking at structured English for given word statement. I am starting with a very simple example, but normally in practice your statements will be very long. When I say customer discount policy, what it really says is that it is a business rule which is used by the company to take a decision on when to give discounts and what conditions should be fulfilled in order to give discounts. So, the business rule says give a discount of 5% if the customer pays advance, or if the purchase is for 10,000 rupees or more and the customer is a regular customer. So, actually if you look at this, there is a, the action is giving a discount, whereas the conditions to be tested are customer paying advance or purchase order is greater than 10,000, greater than or equal to 10,000, and customer is a regular customer. In other words, there are conditions which are three different conditions are involved in this, and an action is either giving a discount or giving no discount. So, if I want to put it in structured English, I will say if customer pays advance, then give 5% discount. If purchase amount is greater than or equal to 10,000 rupees, then if the customer is a regular customer, then give 5% discount, else no discount, end if. And then as you know, else, if and else should be bracketed, and the next else is corresponding to the latest if, namely the that is if purchase amount is greater than equal to 10,000, okay. And then the end if final clauses come first way if customer pays advance, that is for the whole process. You can see here the similarity between this and the way in which you will write a programming program in a programming language, because this can be easily converted into a what is now known as procedural language. Procedural languages are the ones which people normally use, that is C language or C++ and so on, or Java or what have you. So, all procedural languages give a step by step procedure, except that you convert the English statement, because primarily, as I said, the English specification, structured English specification is something which could be understood both by the user and by the developer of the program. So, it is something of an intermediate part. In fact, many people suggest that during the development of a large project, it is important to break it up into smaller parts and then at each level generate the testing to be done, so that testing is done simultaneously with the program development, and so that the testing is not left to the end when you essentially find errors which is not expected. So, this is called test driven programming and so on. So, but then this is only a tool to write a program later on, but at that time from the English statement, it is easier to get the test data generated or test what you want to test, and in fact get these tests cleared with the user, saying that these are the ones I am going to test. So, same thing can be expressed as a decision table. As you can see, it is a non-procedural thing. In other words, it does not say in detail what are done in sequence and what actions are taken in sequence. In other words, in a structured English, you more or less like it is called procedural, because step by step you go, and at the end or during the steps you talk about a certain action to be taken, in this case giving either discount or no discount. Whereas, in this case it is a tabular structure, and at a glance you can say, for instance, the advance payment is made. There are number of business rules. Rule 1 says if advance payment is made, if the answer is yes, then give 5% discount. The other purchase amount and regular customer are irrelevant. So, that is why I put dashes. Wherever condition testings result by testing a condition is irrelevant, you put a dash. If the conditions got to be true, you put a yes, and if conditions got to be false, then you put a no. Rule number 2 says if advance payment is made, that means no advance payment is made, but the purchase amount is greater than or equal to 10,000, and there is a regular customer. The rule says that in that case you give a discount of 5%. Okay. And rule 3 again says that no advance is paid and he is not a regular customer, and the purchase amount is not is greater than or equal to 10,000, even then you do not give a discount. And in the last case, namely no advance is paid, no purchase amount is smaller than 10,000, then you also give no discount. So, this is essentially a conversion of the word statement or a statement of business rules given by the customer to an equivalent table. Okay. And you can see the advantage of this table is that any user can easily visualize these rules. He does not have to know any kind of programming language and does not get cluttered up with a whole lot of if then else statements and then bracketed if then else and so on. So, when the number of conditions increase, the bracketed if then else become a little confusing, and that is the reason why a tabular structure is somewhat more easy to understand for the user. So, conditions are questions to be asked. Yes is yes, no is n is no, dash is irrelevant. An x against an action, if I put an x against an action, that means that action is to be taken, give 5% discount. In the first two rules I put a x against the give 5% discount, and last two rules I say give no discount. So, you use actually a cross against actions which are to be taken and a dash against actions which need not be taken or which are not really taken. So, the rule 2, as I said, I already explained that of the decision table discount states if no advance payment and purchases amount is greater than or equal to 10,000 and regular customer, then give 5% discount. Actions are imperative sentences. See, the imperative sentences are actions to be performed, should be precise and quantified in whether it is structured English or decision tables or any system. The actions which the program is to take have to be quantified. You cannot, for instance, say give substantial discount, because one does not know what substantial really means, whereas give 20% discount has a clear meaning. So, in all cases, particularly in programming, you have to give precise actions to be taken. Very often when people give business rules, they use such terms as giving substantial discount is given, but you obviously cannot program it. What is substantial? You see, is it 10, is it 20, it is 30? I mean, so the whole point is that the ambiguity which is inherent in a English statement, such as English word such as substantial, is removed in the case of a action which is specified. The same structured English procedure can be expressed as a decision tree. It is somewhat like a flow chart, in the sense that you say advance payment is made, then give 5% discount, and you can go down. If advance payment is not made, you check condition 2, which is purchase amount is greater than or equal to 10,000. If the answer is no, automatically you give no discount, and then you test the next condition, which is to ask the question, is he a regular customer? If he is a regular customer and he also has advance is not paid, but the purchase amount is greater than or equal to 10,000, then give 5% discount. So this is the, otherwise no discount. So the point is, here also it is more procedural in the sense that it gives the sequence in which conditions are tested, of course the final action. To some extent, some people are comfortable with this specification, whereas some people, many people are more comfortable with a tabular structure, because everybody is used to a tabular structure in real life. Now we will describe structured English in greater detail. Okay. And in structured English, as I said, it is not a programming language, but still certain types of notations had to be used in structured English, so that there is no ambiguity, and also later on is going to be used by a programmer to convert that structured English into an equivalent program. So if you use there is clarity in the notation which you use, then the clarity in the notation becomes very, very important for converting without any kind of a misinterpretation. Okay. This strict syntax is not necessary, as I said, unlike a programming language, but the strict syntax is necessary only to kind of make it make it so that you don't make any logical errors while developing it. So this is the whole idea of having specific definitions. There are arithmetic operators like plus for add, minus for subtract, slash for divide, and star for multiply, and relational operators usual, greater than, less than, equal to, less than equal to, not equal to, and logical connectives, and, or, and not, which are logical connectives, and there are keywords, if, then, else, repeat, until, while, do, case, for. These are all these, like if, then, else, repeat, while, and so on, are all there in most programming languages. The only extra things I have really put is search and retrieve, which are really higher level operations, and they have to be converted to lower level structures in a programming language. But in structured English, it is easier to understand when you say search and retrieve, because read is there in every language, read and write will also be there, or print or whatever. Okay. And delimiters are the ones which brackets which are used. In fact, end, if, and end for are also delimiters. That means they effectively give the bracketing information. If has got to be bracketed with end if. So that is there to be able to give you an idea that you have not made an error in nesting of the loops, because nesting of the loops really becomes a very often it is a source of many errors, and so the nesting has to be done with fair amount of care, and for that reason we provide the so called delimiters like end and if and so on. Then there are conditional statements like if condition, then carry out a group of statements, else another group of statements, and end if. You can say that if and end if are bracketed. So, if balance in account is greater than or equal to minimum balance, as an example, you can see that if balance in amount is greater than equal to minimum balance, then honor request, else reject request. In other words, it is very simple statement. For instance, when you go to take some money from the bank, they look at your balance in the account. If it is greater than or equal to minimum balance required for that account, then you give the money, otherwise you don't. That effectively is what this says. Okay. The case is number of alternatives which are there, and case, as you know, in any language you have got case statements where it says the number of different, if a variable equal to p, do alternative p, and so on. Instead of having just variable equal to p, you can also have some kind of a testing, but by and large this is because testing is already there elsewhere. The equality testing is something which is very often done, and so the case also says if you check these kinds of things are very useful if you have codes. You have given codes for certain variables, and if the codes match, then you do some action. For instance, you may have given a code of 1 for a person above 25 years of age, a code 2 for a person who is between 25 and 45, a code 3 for somebody between 45 and 65, and so on. Okay. So, when you check the having checked, for instance, either you check it in the program, or when they do it manually, they would just give the code numbers, say 1, 2, 3, 4, and you say whether if the code is 1, do some action, if code is 2, do some other action. So, very often similarly for codification is used not only for age, it is not a very precise example. Another good example of codification is product codes. If you have certain products, all products have certain universal codes given. So, for each product code you may take some different action. So, you can compare project code against what it should based on the truth or falsehood of the variable being equal to the product code, you take some action. Example, say if product code is equal to 1, do a discount of 5%, if product code is equal to 2, give a discount of 7%. So, different products, there are different discounts. In fact, the number can become very large in any business situation, and so the number of the statements within a case may be quite large, and it is a very easy way of seeing what you do. And there is repetition structures, which is there in any programming language. For index, for initial to final, do statements in the loop. Example, start with total equal to 0. For subject 1 to subject 5, do total marks equal to total marks plus marks in the subject, write roll number, total marks, and for. The point is, here you are going through, you are finding out the sum of the marks in 5 subjects, and then finding out the total marks. So, you start with total equal to 0, and at the end of it, of course, you will have total marks available, okay, because subsequently it will be used. It is only a very small part of a program. While is somewhat similar, it is also a repetitive structure. While condition, do statements in the loop, end while. While there are student records left, do read student record, compute total marks, find class, write total marks, class, roll number, end while. Okay. So, here in this case again I have taken an example where a number of records of students are taken one after the other, read, and then some action is taken, and the result is also printed in this case. There is another example. For each item accepted record, you know, when items come into the store, then you as I the very first early examples, I talked about a situation where products are received by a company and sent for inspection, and after inspection if they are accepted, then it goes to the stores, and stores does the updating of the database. Okay. So, in this case for each item accepted, which the acceptance note goes from the inspection office to the inventory control, that is our stores office. Search inventory file. So, the action to be taken by the store is search inventory file using item code. So, the search is a higher level construct I am using here, and if successful, then update retrieved inventory record, write updated record back in the inventory file using the accepted record. There is a number of amount came, which came, and so on is added to the existing inventory record and stored back. Else create new record in inventory, enter the accepted record in inventory file. In other words, it is not already existing in the inventory, it is a new item which has come in. So, then what you do is you enter its code and whatever identifying information is there for that, and then do the rest of it. In other words, put it in the file. Okay. So, this is again repetition, because for each item accepted. So, one by one when the items are accepted, then you do all of this, and maybe at the end of the day you have an updated file which is up to date status of inventory in the store. A procedural language tells how data is processed. So, this is exactly what I was telling at the beginning. It is a step by step set of procedures, or a language which has a detailed about what is to be done, when it is to be done, and so on, and what sequence it is to be done. Whereas decision tables are non-procedural. Most managers and users are not concerned how data is processed. They want to know what rules are used to process data. So, that is the important thing as far as the manager is concerned. Are you using the right rules? Are the rules interpreted correctly? The rules are not interpreted correctly, then at that stage itself, while you are getting the requirement specification, they can change the rules, or if you have not understood the rules as given by the user due to some communication gap, you should at that stage itself with the user's concurrence change the business rules. So, most managers are concerned only about what rules are being processed, rules are being followed. They are not concerned about how you are going to do it, because that is the least of any manager's concern. So, specification of what a system does is non-procedural. See, the case of decision tables is just a specification of what a system does. Decision tables are non-procedural specification of rules used in processing data. The advantage of decision tables are easy to understand for non-computer literate users and managers. In other words, the managers of course understand a little bit of what a language means and so on, but they do not know about details of any programming language or even structured English. Even structured English will be strange to them. Okay. So, whereas anybody understands the table. Good documentation of rules used in data processing. Actually, documentation is as important as the program. In other words, once a good documentation is there, programming writing becomes straightforward. And simple representation of complex decision rules. In other words, representation of a complex set of decision rules becomes at a glance you can see what is going on, and allows also systematic creation of test data, which we will see. There is as I said, while you are developing programs, you should be able to also create simultaneously test data to check the program. Never leave testing to the end. You do incremental testing as and when you go. Tabular representation allows systematic validation of specifications, detection of redundancy, incompleteness and inconsistency of rules. So, these are very important. As I said, very often rules grow over time, and because they grow over time, there is always a contradiction between something which is said earlier or something which is said later, and this contradictions are to be avoided. Also, in some cases rules are not stated, that is called incompleteness. In the case of decision tables, algorithms exist to automatically convert decision tables to equivalent computer programs, and also algorithms exist to check for the ambiguity in tables. I will give an example of how you go from a word statement to an equivalent table. The business rule says that a bank uses the following rules to classify new accounts. A depositor's age is 21 or above and the deposit is rupees 100 or more, classify the account as type A. If the deposit is under 21 and its deposit is over 100 rupees, classify it as type B. If the deposit is 21 or over and deposit is below 100, classify it as C. And the deposit is under 21 and deposit is below 100, do not open account. In other words, if it is 21 or over and deposit is below 100, classify it as C, otherwise do not open. If it is below 21 and deposit is below 100, do not open an account. I mean, of course, the numbers are arbitrary. The age 21, the deposit 100 and so on are just arbitrary. Just I picked it out of the hat. You can actually any given bank will have similar rules which may not be related to age and may not be related to the most often it will be related to the amount of deposit. Now, the first thing you have to do when a statement like this is given is to identify the conditions. When you go through this statement, you see that if the depositor's age is 21 or above. So, immediately I detect a condition, age 21 or above, greater than or equal to 21, that is condition C1. And the second condition is that if the deposit is 100 rupees or more. So, condition 2 is deposit greater than or equal to 100, and there is no other condition, the only age and deposit amount. And the actions which are taken are classification of accounts if they are open and denial if it is not open. So, the actions are classify account as A, B or C or do not open an account. So, having identified conditions and the actions to be taken, the next step is to develop the table based on the conditions and actions. Like the conditions are, in this case, C1 age greater than or equal to 21, condition 2 deposit is greater than or equal to 100, and the actions are classify as A, classify as B, classify as C, and do not open account. There are 4 different actions. The rule, you can go through the rule one by one, very easy. If age is greater than 21 and deposit is greater than or equal to 100, classify as A. If age is less than 21, deposit is over 100, classify as B. If the age is above 21, deposit is greater than, if is not is less than 100, then classify it as C. If the age is below 21 and deposit is also less than 100, do not open an account. Okay. In fact, I am giving every possible rule. If there are 2 conditions and each condition can have a yes or no answer, there will be a total of 2 squared rules. That is 2 to the 2 squared is, that means 4 rules, because I exhausted the combinations possible. Yes, yes, yeah, no, yes, yes, no, no, no. Okay, and each one I take a particular action. Now there is some terminology used in decision table as a terminology is primarily as a definition, so that everybody understands the structure of a table and what it really means, because there is a necessity for some kind of a notation. Just like in structured English there is a need for a notation, in the case of decision tables also there is a need for a certain notation, and that notation, in this case the conditions are all put together in the left corner of the 4, it's a 4 quadrant, the table has got 4 quadrants. As a left top quadrant, and there where the list conditions are listed, this is called a condition stub, and the one below it on the left hand side of the double line is called the action stub. There are the actions to be taken. So the condition stub is states the conditions in to be checked. The action stub lists the actions to be taken, and the entries, the condition entries, which is the which is there on the top right hand quadrant, is the are the answers to those questions which are asked, and the below that is called, there are called action entries. So there is a condition stub, action stub, condition entries, and action entries. So I am summarized that here. So there are 4 parts, and the 4 parts are divided by 2 double lines. Okay, just to 4 quadrants demarcated do 2 double line. Condition stub lists all conditions to be checked. Action lists all actions to be carried out, and a table is called a limited entry decision table if the conditions, the answers to conditions are either yes, no, or dash. Dash is irrelevant. That means whether the answer is yes or no, does not matter. Okay. So that irrelevance is shown by a dash. X against an action states that it has got to be carried out. A dash against an action states it is to be ignored, not to be carried out. Entries on a vertical column specifies a rule. In other words, as I read it out, each vertical column here, rule 1, rule 2, and so on, each one specifies a rule where you test the condition and take appropriate action. Very important one, very important point about decision tables, which makes it non-procedural and which also makes it somewhat simpler to understand and later on to process by computer to detect ambiguity and so on, is that the order of the conditions is irrelevant. That is, conditions can be tested in any order. Now I can even if I write C1, C2, C3, I can reorder it at C3, C2, C1 or any order, and does not really matter. That is for a simple reason that each rule will depend on the answers to all the conditions in that step, and what order I check should be relevant in the case of tables. In other words, the definition of table says that order of testing conditions irrelevant. However, order of listing actions is important. That means if an action is listed first, it is taken first. If an action is listed number 2, it is got to be taken next, and so on. So there is a sequencing of actions, whereas there is no sequencing of conditions. So sequential execution of actions, and rules may be listed in any order, because conditions can also be listed in any order. Rules can be listed, can change around the order of the rules, because ultimately each rules, where it occurs, is irrelevant as far as the job is concerned. There is one more type of a decision table which has got something called a else rule. In other words, else rule is cover all. In other words, in all cases which are not specified strictly in a set of rules, all that are clubbed together and you take one common action. It is like the else in a if then else thing, except that in this case the else may encompass many possibilities. So for instance, a business rule says that if application is sponsored and his dues have been paid, these are rules for admission of students to a particular short term course. So the applicant is sponsored by the organization to attend the short term course, and if he has minimum qualifications to profit from that course, and if his fee is paid, then send an admit letter right away. Okay. If the applicant is sponsored, he has minimum qualifications, but the fee is not paid. So you have already filtered the application and found out that he is eligible, but his fee is not paid. So send a provisional admit letter which may state that kindly pay the fee by such and such date for your admission to be valid, otherwise you will not be admitted. Else in all other cases send regret letter, because if the application is not sponsored, automatically see, and if it does not have minimum qualification, then also it goes automatically. And you can say, because S and S are covered, anytime any one of the first conditions is a no, the last condition is irrelevant. So anyway, in any case, in all these cases you effectively say that send a regret letter. Okay. The else rule actually makes the decision table complete. What I mean by decision table complete is that all possible contingencies, all possible rules which can occur are covered. So in other words, even if you miss out something, it is an exception action, and sometimes it could be quite dangerous to take an exception action. You have to be careful in using an else and clubbing a lot of things together in the else. It is better to always look at the complete part. There is another table here, which the reason why I put this table is here the action testing, the sequence of testing actions becomes relevant. Okay. This is a set of rules for to be given to a supplier, okay, and when the order is be initiated. Okay. The quantity ordered is less than or equal to quantity in stock, and quantity ordered minus quantity quantity in stock minus quantity ordered is less than or equal to reorder level. That means it is above it. Then the quantity shipped is equal to quantity ordered. See, because you have this is a rule, okay, and then you update the quantity in stock as quantity in stock minus quantity shipped. So the point really in this case is the fact that you first do the quantity shipped is quantity ordered, and then you do the this is a kind of a set of rules for a vendor to follow when the order comes to him and he has to supply. So when quantity ordered is less than, that is, he's got enough stock in his inventory, and it is above the reorder level, then he can immediately ship the whatever is the order and of course update, that is whatever is shipped is reduced. And the next rule says the quantity ordered is less than or equal to quantity in stock, that means he has got enough quantity to ship, and quantity ordered is minus quantity quantity in stock minus quantity ordered is less than or equal to reorder level. Yes, if it is below reorder level, that means the vendor in order to has to kind of bring up a stock to a certain level, because any inventory control of a vendor, whenever he supplies items. I took an example of a medical shop, for instance. Medical shop, when a customer comes and buys some medicines, he notes down whether there is enough left in the shelf. If it is not enough left in the shelf in terms of what he considers a reorder level, he will order that, he will reorder that amount, otherwise he will not do it. So in this case, it is important to kind of the rule says that you ship the quantity and then initiate the reorder procedure right away. That means you are calling another program, you might say, to which will initiate the reorder procedure, and then you update the quantity in stock by removing whatever is supplied. Okay. The third rule says the quantity ordered is less than or equal to quantity in stock. In other words, he has ordered an amount which is larger than what you have in stock. That means you can't supply the entire amount. You can ask the customer when whether he will take a partial order. In other words, suppose you ordered 1000 and you got only 800. You ask whether he will take 800 or will take 1000 and nothing else. Okay. In some cases he may not. So if partial shipment is not is okay, then you ship the quantity. Your quantity in stock automatically becomes 0, because the quantity ordered is greater than the quantity in stock, and and you have to kind of have a back order file. In other words, you have to supply 200, but you didn't supply later on. So back order, put on the back order file quantity ordered minus quantity shipped, so that you ship that amount, and then initiate reorder procedure automatically. You have to do that because you have no stock. And the last rule says, if quantity in stock is ordered is greater than quantity in stock, you don't have stock, and the customer will not accept partial order. That means you don't ship anything. Quantity shipped is 0, but you have to reorder, because he may ask for the same item, or somebody else may ask for that item. So reorder, and so back order of course is what is to be shipped later on. If he asks for 1000 and you don't have 1000, he is not willing to accept the partial quantity, then you put the 1000 in the back order file, and when you get enough stock, you supply 1000 to him. At that time, of course, there may be one more business rule saying that if the delay is more than 3 or 4 days, he will not accept. Okay. So, that would complicate. In other words, the business rule may be more complicated than this, but this gives a sample of the business rules normally used for, in this case, when an order comes to it is called an order processing system. When an order comes to a vendor, how does he process that order? What rules will he follow to process the order? Okay. And it is a very, very elementary example. I mean, just to so that I can fit in the whole thing in one transparency. Normally, order processing procedures in many companies will be quite complex. They may have many conditions to be checked, and I will come to that later on in terms of what happens if the number of conditions become too large. So far we looked at tables where the entries, the condition entries are only yes or no or dash. These types of tables are not restricted in the terminology of decision tables. Similarly, actions I put x or dash, and there also is not really the only actions you can specify. There is something called an extended entry decision table, which is a little bit more descriptive than the limited entry table, and which also can be converted easily into a limited entry table almost automatically by a computer program. Okay. In any case, the advantage of an extended entry decision table, it is easy for people to understand. See, the number of rules will become somewhat smaller, and it will be easier for a non-computer person to understand the rules, and again it is non-procedural. Okay. Because non-procedural, it is, as you said, it is going to be again easy for a person to understand. So, in this case, the product code is 1 and customer code is A, and ordered amount is less than or equal to 500. You see, in this case the rules are not yes or no. Okay. I have put the actual values of product codes. In this case, the product codes are either 1 or 2. In the case, if a product code is A and customer code is also, there are 3 possible customer codes, and order amount, there are 2 I am using. One is less than equal to 500 or greater than 500. Okay. So, this again is a discounting policy of a particular company. The way in which I read these rules is that if the product code is 1 and the customer code is A and the order amount is less than or equal to 500, give a discount of 5%. If product code is 1, customer code is B, and order amount is less than or equal to 500, give 7.5% discount. And third rule says that product code is 1, customer code is A, order amount is greater than 500, give 7.5% discount. You see that there is a difference between rule 1 and rule 3. Rule 1 is for less than or equal to 500, and rule 3 is for greater than 500. These two cases, there are 2 different discount policies. And rule 4 says that if the customer code is B and order is above 500, then give a 10% discount. That means, again you see the difference between R2 and R4. First 2 conditions check, the third condition is different, and so the actions are different. Okay. And the codes may be assigned based on the convenience or based on whatever policy a company follows. A type customer may be a different type from B type customer, and so on. If the product code is 1 and the customer code is C, then give 6% discount, and if the product code is 2, give 5% discount to everybody. Now, in the case of product, customer code of C, it does not matter whether it is 500 or above and so on. So I put a dash there to say that that condition is irrelevant. So the only first two conditions, namely product code equal to 1 and customer code equal to C, has to be checked, and I ignore the third condition and I take the action of giving 6% discount. And if the product code is 2, then a flat discount of 5% is given to everybody. Okay. So this is what this particular table says. I can interpret it rule after rule. The reason why I am doing it, I could have done the other way around. In other words, I could have started with a set of rules given and converted the rules into an equivalent table, which I did in the previous case, say the very first example. In this case, the reason I am doing this is to show you how simple it is to explain what the table is to any person, and that is a great advantage. See, that is the greatest advantage of a tabular structure. You can also mix up the extended entries with limited entries, and it is called a mixed entry decision table. In this case, you can see the product code equal to 1 or 2 are the only two alternatives. So I am able to say yes, 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 and no, and customer code is in fact there should be a yes on the first the rule 1, there should be SAS. Okay, the Y unfortunately is missing in the typing, so it is a printing error. So it has got to be YAY, product code is 1, customer code is A, and amount is less than 500, then 5% discount. It is same table put in a different form, where I put yes or no together, because the yes and no in some cases and codes in some other cases. The reason why this will work in the mixed entity is called a mixed entity table. You use mixed entity table wherever the condition to be checked has only two alternatives. Like in this case, you have only 1 or 2 as two alternatives. So you can say product code equal to 1 or no. Okay. Similarly, order amount is only less than 500 or greater than equal to 500. So that is the reason why I can say use yes or no. See. So this kind of a table is also allowed. In other words, in the notation of tables, both limited entry tables, in fact limited entry tables are the ones which are very useful, and also is one of the earliest kind of a tables which people started. And later on we will see that it is a very useful thing to have from the point of view of actually automating the process of converting into a program, also to some extent generating programs, I mean the generating test data and so on. But there is no, depending on the situation, depending upon a particular situation, you could either use limited entry or extended entry. See, as I said, the convenience would be based on the types of alternatives and the number. If the types of alternatives are large in number, then instead of increasing the number of conditions, I could actually put codes ABC. In other words, if I had used a limited table in this case, then see, what I would have to do is customer code equal to A, I had put yes or no, customer code equal to B, yes or no, and customer code equal to C, yes or no. So the same condition 2 will kind of get expanded to 3 conditions, which will unnecessarily clutter up the table. Okay. So in the case of things like codes, it's somewhat like case statement. The case the codes occur, it somewhat doesn't clutter up the structured English program. this is you can link decision tables together. The linking means that the one table can lead to another table, which can in turn lead to a third table. In other words, there is a sequencing of tables possible, and linking is very important and necessary in very complex problems, for a simple reason that suppose I had not linked all of this. You see the table number 1, there are 4 conditions. Table number 2, there are 3 conditions, and table number 3, there are 2 conditions. So if I add 4 plus 4 plus 3, 7 plus 2, 9. So 9 conditions. If I put all 9 conditions in one large monolithic table, there will be 2 to the power 9 number of rules I got to cover, and 2 to the power 9 is how much? It's 512 rules, and nobody will be able to understand it clearly. So it is very important to also in any table limit the number of conditions to be tested in a particular table to a number which is again somewhat like magic number 7 plus or minus 2. Even 9 is in fact is too much. Normally you try to keep the table with not more than 6 or 7 conditions. Okay. If it becomes larger than 6 or 7 conditions, then you start trying to linking up with other tables. Then break up the table into smaller parts, somewhat like leveling in DFD. Okay. You have one complex table, you got to kind of break it up into smaller tables, just like in a complex DT, the complex DFD, you break it up into leveled parts. Similarly, in a complex decision table, you kind of make it into linked parts, which are all using the same conditions, but at a finer level, a level where the conditions are limited. In this case, I will interpret the table like this. If there is a set of promotion rules which is given to a company in terms of under what conditions should a person be promoted or not, and I would let you look at this with some care and interpret yourself and try to get to the business rules yourself, and you will understand how the linking takes place. Almost almost self-evident the way in which it is done. So next time I will start with this point and explain this linking issue, and also the conversion of this into an equivalent word statement.